So you're right. He has problems now, but he's lived till what he's about 80 to 85, and he's
Well,
lived a
think about
decent
the
life.
first 50 years of his life. Was he around any of the things that you are? How old are you?
I'm 28, but that's
All
a
right, well,
very good point. Yeah,
there's the key. And remember
I
that
agree.
the point that people forget is that what people have sensed in the 30s, 40s, 50s, and 60s, even the 70s, it's radically different than what's happened since 95.
Okay.
When 95 came, that's when the internet went from hardwired to Wi-Fi, and it's when all cell phones became bi-directional microwave devices. In other words, only the rich people before you were born, I grew up in New York City, so I can remember this. Only rich people had microwave ovens in the 60s and 70s, even into the 80s. Now, guys your age don't even understand that because a microwave oven, you can go to Best Buy and cost you like 89 bucks. Well, that
Mm-hmm.
wasn't the case, back when, Buffett was in his heyday in the 60s, 70s, and 80s. The point that I would make is, and I always say this to the people on my forum, and I'm going to say it to you, you have to have the appropriate context. And you know what? I find people below the age of 30, 35 have no context because you guys grew up in a completely different world
Mm-hmm.
than I did. I mean, I'm 50 years old, and Buffett's older than me. Musk is probably around the same age I am, maybe a little bit younger. But you have to realize where you live and what you're around kind of dictates the environment that your mitochondria senses. And what I like to tell people, so they understand this without the crazy science, I like to give them the analogy of a direct TV dish. Most people have had the experience of having a direct TV dish, and when they have thunderstorms like we've got right now in New Orleans, and they're watching the NFL game, the game gets wiped off the TV. Everybody says, okay, that makes sense. Well, that means there's excess energies in the environment, and that's able to do that. How do those signals work? Those signals work the same way that electromagnetic radiation works in you. So your personal thunderstorm can wipe off the program that's built into your mitochondria that handles electrons and protons. So your personal thunderstorm dictates the way you can handle electrons from food. Uh, it's really important. Then when you take it to the next level, which is where I think the biggest risk for modern humans is blue light. And the reason why blue light, which is also the number one non-native EMF that's out there, blue light radically affects how mitochondria work. And this is an effect that no one seems to realize. But if do a PubMed search or just look, even superficially, you're going to find that the data that's out there is incredible. The problem is no one is connecting the dots and explaining it to people so that when they go to their primary care doctor, they're starting to realize that carbohydrates fundamentally are a problem for diabetics, but they're not the problem.
Right. So yeah, I that's why I'm interviewing you because I really like that you're really piecing things together, and I completely to electrons and quantum theory.
That's pretty simple. Anything that's a stressor, whether it be metabolic, emotional, biologic, everything affects the paraventricular nucleus in the brainstem. And what is that for your listeners who don't know? It's a nucleus in the brainstem that controls the sympathetic outflow. There's two systems in the brain. One's parasympathetic, the other one's sympathetic. Parasympathetic is the one that calms things down. It's basically the rest and digest part of the brain. And the other side of the brain, which is the sympathetic side, is the one that we have a problem with when it becomes with non-native EMF. What does that mean? It releases calcium. Calcium efflux is how that starts. It's the major second messenger in neurons. When that happens, neurons get turned on. We have a chronic stress response. So you can get a chronic stress response not only from your job, your wife, your girlfriend, your boyfriend, but you can actually get it from a cell tower that's close to your house. You can get it from the 60 hertz signal that's in your bedroom right now. You can get it from a variety of different things. And are there scientists who've already done these physics experiments through some very, very slick testing called ion cyclotron resonance that have proved beyond a shadow of a doubt that even low electric and magnetic fields can cause calcium efflux? The answer is yes. The problem is no one's reading what they've written. And this will shock you since you're 28. The guy whose book, in my view, is the treaty on this is a guy named A.S. Pressman. It was published in 1970. Dr. Andrew Marino is a physicist who was Robert O. Becker's right-hand man, took it further and wrote a book called Going Somewhere that documents exactly what all this stuff was and what the state of the science was and what happened in New York City about power lines that went from New York City up to Ontario to Niagara Falls in 1977 that basically caused Dr. Becker, who was twice nominated for the Nobel Prize, to basically lose his funding from the NIH in 2 weeks.
Oh, wow.
And he retired at 56 years old. And just so you know, because I know you may not know this, the reason I'm very well acquainted with Dr. Becker's work, he was an orthopedic surgeon at SUNY Syracuse, okay? And I happen to be a neurosurgeon. I'm a spine surgeon. Well, Dr. Becker, his world-famous research was on bone physiology. He was the guy that figured out that bone doesn't heal. It actually regenerates. It's one of the only tissues left in humans that still has the same ability that's found in amphibians. And it works on the photoelectric effect, piezoelectricity, and he, in 1963, if you can believe this, wrote a paper in Nature that proved beyond a shadow of doubt that bone is a semiconductor. When I was in residency in the late 80s and early 90s, his work was required reading for us in residency. And I have to be honest with you, this is after medical school and actually a lot of training. I had never heard of this. And when I read these papers, I was like, how in the hell did I get through medical school and never hear that bone was a semiconductor and that worked on a P and N junction and all this? And it just never stopped me. And when I went through my transformation 10 years ago, that's when it dawned on me that Becker's work was critical in understanding kind of what was going on. Because if you understand that one system works on semiconduction, you understand that semiconduction can be affected by non-native electric and magnetic fields, then you as a clinician need to realize that you just found the canary in the coal mine for humans. And 10 years ago, I started realizing that everybody that walked into my clinic had some form of either osteopenia or osteoporosis. And I was like, wait a minute, how can everybody on the planet have this problem, even though they don't have the classic risk factors that doctors talk about? And that's how I went down the rabbit hole that I went down. And I realized that it has to do with the change in the physics of our environment. Humans have changed the overall physics of our environment. And they've changed it in a variety of different ways. It's not just one way. It's kind of like, the best way to describe it, it's kind of like a slow erosion of the mammalian battery from a multi-directional approach. And that's where we are now in 2015. And I grew up in a world very different than you. I didn't have any of this stuff. The only thing that we had to deal with back then was the 60 hertz system, some power lines in New York, but we didn't have cell phones when I was young. We had TVs, but most of them were black and white.
Right.
So it was a different time. I personally think that your generation is going to get sicker faster from more serious diseases than any other generation in history. And if you talk to any physician right now, they will tell you that the acuity rate of people coming through a primary care doctor's office and my office has changed dramatically. I've seen this in my own career. There is not a surgeon I haven't talked to that doesn't have my perspective. The problem is none of them understand why. And see, I decided to be a little bit more curious, try to figure out why it was going on.
Right. So, 100%. I agree that the world is definitely changing. I'm seeing, just everybody's really come down with a variety of issues. They're having energy problems. What I see is that people, a lot of times, like a lot of problems comes after a large bout of psychological stress. And so you're saying that has to do with calcium efflux. And I've actually done some research on it. And you're right that EMFs do cause calcium efflux based on some animal studies that I've read. Is that the mechanism by which it destroys mitochondrial function, the calcium efflux?
Well, it's one of the ways. There's a lot of other ways. It depends on what we're talking about, whether it's the electric field or the magnetic field or a combination of both. But I'll give you the flip side of a non-native EMF, how it does it even quicker. Blue light actually destroys melatonin in your brain. When melatonin goes down, the other thing that happens that's very important is you lose DHA in cell membranes everywhere in mammals. So why is this important? Again, this ties directly to Becker's work. Becker found that in salamander, just about every animal, including humans and plants. So I want you to realize we're talking about major coverage here in terms of things that are alive, that the DC electric current is directly tied to regeneration in plants and animals, amphibians, salamanders, you name it. Well, when you have no DHA in your cell membranes, what do you lose? You lose voltage. How can you, my friend, or any person listening to this, go get this checked very easily? Go get an EKG, go get an EEG. You're going to notice that the voltage decreases when you have whatever stressor you think you have. Problem is, are doctors doing those types of tests? Yes, but are they linking them to your environment? The answer is no. They don't understand how that linkage happens, okay? But that linkage happens via DHA. What is DHA special about? Most people know DHA is fish oil. DHA is concentrated in every eukaryotic membrane. As you go further along the evolutionary tree to us, we have 3 pounds of it in our central and peripheral nervous system. So we're designed to concentrate it. The other thing that's interesting about humans is we don't make it endogenously. In other words, we have to eat it, okay? And taking a pill doesn't obviate that risk. It has to be in your brain. Here's where it gets interesting.
Wait a second. We don't make it. I thought we converted it from alpha-linolenic acid.
No, humans have hardly any ability to do that. And that research has been published for probably 30 to 35 years. And the world expert on that is a guy named Michael Crawford and Stephen Cunane. They've written books and multiple articles on it. One of the only mammals that has the ability to make a lot of DHA endogenously, which is part of the reason why I eat it, is lamb. Okay, but not all mammals have this ability. Humans really don't have it, and that's one of the big vegetarian myths, that they think you can eat flaxseed and make DHA. Not true. Completely not true. Getting back to the DHA story. Why is DHA fundamentally linked to this DC current of regeneration? DHA is the only lipid in 600 million years of eukaryotic evolution that is able to turn sunlight into a DC electric current and vice versa. It can turn a DC electric current back into sunlight. Now, why is this important? Where is DHA highest in humans? In your eye. Why would it be highest in your eye versus your brain? What goes through your eye, my friend? Sunlight.
Photons.
Right, exactly, sunlight. And what sits right above your 2 optic nerves where they cross, in the geographic center of your head? It's called optochiasm. There's this little thing called the suprachiasmatic nucleus. And what does that control? Controls circadian biology, okay? And why does your suprachiasmatic nucleus require a higher level of DHA in your eyes? Very simply. And this goes right to physics, because it has to run faster than all the other clocks in your body. Why is that? Let's stop for a minute. Here's where we take a physics detour. Almost everybody listening to this knows about Garmin devices and GPS devices. Everybody's got one on their iPhone. So how do they work fundamentally? If you look up right now outside your window, wherever you live, you'll see that there's devices, satellites that have atomic clocks in it. They have to run 38 microseconds faster to run the devices that are on the surface of this planet. Why is that? Because gravity bends light. Okay? That's the fundamental physical reason it has to happen. Okay? It's called gravitational lensing. So if you didn't account for that and the clocks that were in orbit didn't run 38 microseconds faster, you would be off by 10 kilometers on the surface. So how good would your iPhone or your GPS device be, in getting you from point A to point B? Not very good. Now let's take it back to you. Why does your eye have to have more DHA? Because the clock in your head has to run faster than the clock in your liver, the clock in your feet, the clock everywhere else in your body. Why? because biochemistry will be off. You'll develop chaos. What happens when arrivals and deliveries in a cell come at the same time versus being yoked in a proper fashion? We call that chaos. What's another name for that? A synonym is called inflammation. What does inflammation got? Inflammation has a positive charge. What does DC electric current filled with? Negative charge. How do you get rid of positive charge? With a negative charge. Hence, this is how it links directly to Becker's work. And the problem is, people don't realize, to take this even further, to prove to you that I might be right, do you know that in front of every single mammalian gene in the genome, there's a circadian clock gene called Pier 1 and Pier 2? Do you know why that's the case? Because that supracosmatic nucleus has to yoke gene expression via those two clock genes. And the thing is, biology has known this for literally 25, 30 years. They just have no clue how it works. And here's the irony. Every single one of you listening to this can fact check how a GPS device works. It works exactly the same in you. The problem is you don't have a clue how it works in you. And when you begin to understand that blue light destroys DHA in your eye, that's why melatonin drops. So what does that mean? It means that your clock in your supracosmatic nucleus cannot run faster than the one in your liver. And when that happens, you get a disease called diabetes.
Interesting. I've noticed that probably half of the people I deal with have problems with their eyes hurt when they look at bright light. And I'm assuming, based on what you're describing, that has to do with a DHA deficiency in the eye. And then I'll ask you, well...
I would stop you there.
Oh, okay.
It doesn't have to do with that. It has to do with excessive blue light.
Yeah, but that's because they're not having enough DHA.
Well, here's where it gets interesting. You have to look at this as an equation. You can live in a blue light world if you eat like a great white shark. Now, my day job as a neurosurgeon, no one lives in more blue light than I do. Why is it that I don't have the problems that I should have based on the theories that I publish out on my blog?
Because you eat a lot of DHA.
Right, but I also limit my blue light exposure the days that I'm not in surgery. I do things radically different.
Do you wear red glasses to limit your...
I do.
In the daytime as well, though?
Yes, I do many different things to mitigate my personal thunderstorm. It gets back to what I told you earlier. You have to assess your personal thunderstorm and what your life requires, and then you build your biohack and how you're going to live your life from that standpoint. So when you have big risk, that means you have to do more. You have to be more aggressive. When you don't, then you can change the mix.
All right. The question is, I've thought about doing this, like wearing red glasses in the daytime, but the problem is I was always afraid that I'm going to ruin my circadian rhythm, because you need blue light in the daytime to set those clock genes.
You only need the blue light in the beginning of the morning. That's it.
I see.
If you were following the leptin prescription, what does it tell you to do? As soon as you wake up, you go outside, not behind glass, not behind those glasses you're wearing, and let the sunlight hit your retina for about 1 to 3 minutes. What does that do? It tells your brain the sun just rose. After that, it becomes an endogenous clock. It doesn't need constant. It's one-time effect. But as soon as you wake up, within 30 minutes, you need to get outside naked and let the sun hit you. Now, where you live, it looks like you live someplace in the city. That's probably not going to work too good. But that's the stuff that I do.
I still do it anyway.
Yeah. Well, I would just tell you that that's how it works. Once that clock is set, the brain takes over the internal clock mechanism, and then things can happen from there.
That's very good information.
Yeah, the real thing that you got to worry about with the glasses during the day is that they can make you sleepy. So if I recommend no one drives with the glasses, because it'll raise your melatonin level. But I would only tell people to do that if they have extreme blue light issues. And the way to know that is you have to biohack your own environment. Most people don't know that. The guys on my site do, because they do that all the time. They've been learning with me for 4 or 5 years how to do that. And then they make the appropriate adjustments based on their own biohacks to figure out what, in effect, they have to do to protect themselves.
Okay, quick question. I have a bright light device actually here. You see, so I'm assuming you're not going to like it but there is research that the bright
You
light.
don't assume anything because
Okay.
you're making a bad assumption.
Okay, sorry about that. Yeah.
Because bright light does have a role, but you're
Okay.
missing the point. Just by your questions you're asking me, you're not thinking correctly.
All right.
Okay? Bright light has a role. It has to be in a circadian role. Okay? The problem is you're trying to replace fake artificial bright light with sunlight because you live in a very bad place.
Mm-hmm.
Okay? You're not willing to give up what you need to give up. And that's the reason why the research has shown that those bright lights can help. The problem is if they're not applied appropriately, it can throw your circadian rhythm off. And that's what we're starting to see. The best data out there for bright light therapy is for SAD, which is,
seasonal affective disorder.
Exactly. And that's where it plays a role. Here's the key. That disease doesn't affect many people. What's the major circadian mismatch disease we have today? Alzheimer's disease and type 2 diabetes. Also autoimmune disease. Now, how many people have that compared to SAD? So why do you want to focus in on something that's not important instead of something that really is important? See, I look at it like this. I go after the big diseases. Why? Because that's going to have the biggest benefit to my species. And the only way you're going to understand this is understanding the context of how to use these physical factors.
Okay. You made some very good points. Now, I have a question about, you speak a lot about DHA and oxygen. Now, the way you explain it is, and this is certainly very true, that you have in your mitochondria, your inner membrane, you have a electron flow, and you say that that's important to have a very good electron flow so that your magnetic field is much stronger. And the reason why you want your magnetic field to be strong, or at least two big reasons, is to attract DHA and O2, which are paramagnetic, and so that's attracted to the mitochondria. Did I get that right or no?
Close. I mean, it's close. It's good enough. It's good enough for the people to understand. So, what's the question related to that?
Well, no. So, is that what I wanted to know? Is that the main thing? Why do you want to get your magnetic field very strong? Is it because
you get it strong?
Is it because the DHA, the O2, or to increase ATP production?
Well, here's the key. Anytime, you do have to know a little physics. Anytime you have an electron flow going across a membrane like you do on the inner mitochondrial membrane, Maxwell has 4 equations. What does it say? As electrons flow through, you develop a magnetic field at 90 degrees to that electron flow. The 5th cytochrome is called the ATPase. The ATPase has a rotating head. Why do you need that 90 degree? Because that's what spins that rotating head to make ATP. What does ATP do? If you listen to biologists, they tell you it's the high energy phosphate. Gilbert Ling has told us that it's impossible because it breaks the second law of thermodynamics by 5-fold. So Dr. Kruse does not believe what everybody else believes. He believes Gilbert Ling. So what does ATP fundamentally do? It unfolds proteins so water can bind to them, okay? Now, during the daytime, magnetic field strength is relatively low, okay? That's because light's present. It's higher in the day, but the endogenous or native magnetic field on the Earth is very low. We're talking between 20 and 100 microteslas. So what did Becker tell us in his research? The higher the magnetic flux you feel, the more sleepy you get. In other words, it helps regenerate. So do you want a high magnetic field during daytime? The answer is no. You want it at nighttime. That's the reason why you sleep on a magnetic field.
I see.
Got it?
Mm-hmm.
And you have to realize, just normal diurnal variations in physics, when the sun is shining, magnetic field on the Earth from the Schumann resonance is lower. At nighttime, it increases. So these are all physical forces that your biology pays attention to. How are these things codified in your brain? Because I want to make sure you understand this. The alpha wave of an EEG, okay? So if you were to get an EEG and you wanted to see if you had a circadian mismatch, what would you look for? You would look for a loss of alpha wave voltage. And guess what? When I do this, since I am a neurosurgeon, and I do it relatively frequently, what do we see? Certain people in certain diseases Let's talk about it. Obstructive sleep apnea, type 2 diabetes, and Alzheimer's disease all have diminished or absent alpha waves. What else do they have? Which gets directly to your point. They also have
hypoxia.
You got it. And why is that a big deal? Because what do we know from Einstein's photoelectric effect? In order to make free radicals in your mitochondria, which are what make new mitochondria, you have to have a stream of electrons hitting some transition metals. Guess what sits in the mouth of every cytochrome? Iron, manganese, and copper. And those electrons energize the D shell electrons to do what? To make free radicals. What's the number one free radical made in mitochondria? It's called superoxide.
Yeah.
You got it. And why is a superoxide a free radical? What does a free radical mean? It has an unpaired electron.
Unpaired electron, right.
What is another one? Hydrogen peroxide. It has an unpaired electron. What's another one? The hydroxyl free radical. It also has an unpaired electron. Humans have enzymes to control the first two. It doesn't have anything to control the last one. So the more stress you make, the more hydroxyl free radicals you make. What is the effect of the hydroxyl free radical in excess in our body? It destroys cell membranes, destroys DHA. Oh, we're back to that story again. Now, what happens with low superoxide? You make superoxide from oxygen. Why is oxygen important? Well, it happens that there's this thing on the inner mitochondrial membrane, iron and manganese, iron and copper hold oxygen together to make the superoxide. It strips an electron off. The binding of oxygen to that membrane is electrostatic. What does that mean? It means it's directly controlled by electric and magnetic fields generated within that mitochondria. So if you have an altered electric or an altered magnetic field, can you hold oxygen in order to take that one electron off to make superoxide? The answer is no. So this is the reason why everybody who has type 2 diabetes, Alzheimer's disease, Parkinson's disease, if you measure their superoxide level, you'll find it's absent. And that means if you cannot make free radicals, what does that mean that you cannot do in biology? It means you cannot make, you got it, exactly right. And that means that you have to work on old mitochondria that's defective. Okay?
This is a very interesting point. I've actually studied I study this point, and specifically I realized conditions like brain fog is actually a result of too much superoxide in my view, and
or too little. See,
right. So it was in my view, and now you're saying, well, it could be too little, which
correct.
I didn't think of before. Well, I understand it though, because you're saying if it's too little, it's not going to cause the gene transcription for new mitochondria. That certainly makes sense. And also, there's they have done research on various kinds of free radicals. They do stimulate mitochondrial biogenesis.
Let me give you the
nitric oxide paper.
Let me give you the number one paper you need to read, because it was just published in 2013 by David Sinclair. It's in Cell Metabolism. You can look it up.
I read it.
The paper's amazing, okay? The problem is it doesn't go deep enough, but everything that I just told you in the last 5 minutes is completely supported by his paper. Realize that I came up with these ideas 10 years ago, before there was any research out there. Why? Because I gave up my biologic perspective and put my thermodynamic engineering physics mind to work. And when you understand the physics of things, I personally believe that figuring out biology becomes way easier. But do I have to continue to look in the biological literature for guys like you who are skeptics? You're going to find out that 10 years ago, I was really a crazy mofo. But you know what happens? Every year, I get more and more right. And this is what I tell people. When you get on my site and you read my quilt document, realize that I wrote that 10 years ago. My whole goal, I knew what I had found was very counterintuitive. So every time I add a new blog, it gives you a new piece to the puzzle. And what does that do? It acts just like a fractal. It acts like a hologram. You're getting a new piece so that you begin to see a new picture. It's kind of like looking at Van Gogh's painting. If you saw it with just white paint and you didn't see it with any other colors, you'd say, I don't see Starry Night. And then he starts adding all the other layers. And all of a sudden, when he's done, holy shit, look at that. That picture rocks. Well, I'm trying to do the same thing for you, because I realized 10 years ago that nobody would see what I was seeing because they didn't look at biology the way I was looking at it.
100%.
And that's the key. And the key is I continue to do that. And the people who've been following me for 4 and 5 years, it's amazing to me. The number one thing they say is, Jack, I go back and read the old blogs, and all of a sudden it makes sense. And what do I tell them? Because now you're seeing it with new eyes. You're seeing a different perspective of something that you didn't perceive. And it just happened to you when I said to you about superoxide. Everybody assumes, because the antioxidant theory of biology is, oh, that all free radicals are bad, when it really turns out that free radicals are good.
Right. In bursts.
Right. Correct.
So, yeah.
The dose makes the toxin in everything, including free radicals.
Right. So, yeah, no, what I found was actually, so that was my theory, the superoxide theory of brain fog and various issues. And then what I did was I looked at the genetics. So I was looking at genes, and I was looking at genes that break down superoxide. And it turns out that the people I deal with who have, brain fog, most of them have a gene, and it's only 20% of the population, that doesn't produce enough manganese superoxide dismutase to break down the superoxide, and that would cause elevated levels of superoxide. But you're also saying that it's the lack of superoxide that can also be a problem. Now, I'm wondering if this has to do with a difference that we also see in people. You mentioned that obese people have an energy problem.
Mm-hmm.
And in my experience, thin people also have an energy problem.
Well, you have to qualify that, because people listening to this will get confused. You're talking about people that are excessively thin.
Well,
I'm not talking about regular fit people. See, there's a big distinction here. People who have below the normal weight and people who are above weight, they're both leptin resistant. Normal people aren't leptin.
Well, let's say take me for an example. Most of the people that I deal with have they're not too thin, but I'm not thin. I would say I'm pretty average as far as.
I would disagree with that. I wouldn't let you off the hook that easy, because if I did an MRI on you and looked on your insides and got a